Hello everyone, welcome back to this array series in JavaScript. So today's question is that we have to move all the non-zero elements, to the end of the array, to the end of the array. For example, if your input is 2 comma 0 comma 0 comma 1 comma 4, then output will become 2 comma 1 comma 4, and zeros, how many zeros? Two zeros. So two zeros at the end of the array. Okay, so all the non-zeros element at the beginning and zeros element at the end. So method 1, what we will do, we will start from here, we'll start the iteration over here, and we will keep checking the non-zero elements, and we will take a count of the non-zero elements, and we'll, like, that will act as an index, and this is 2, so it will be as it is here. 0, no, okay, 1, so it's a non-zero element. So what we have to replace this over here. Again 4, non-zero element, so, and this counter will be plus plus, so again this will be at the end. And then once all these non-zero elements are at the beginning, and then what we have to do, suppose we get all these non-zero elements at the beginning. Now the remaining places, we will start a loop from the remaining, from here to here, and we will put zeros at the end. Okay, so let's quickly understand this through the code. For I is equal to 0, let I is equal to 0, I less than n, I plus plus. N is the length of the array. Okay, and initially we will declare let count is equal to 0. Okay, let's erase this. Count is equal to 0, it will track of non-zero elements. Okay, so if array of I is not equal to 0, if array of I is not equal to 0, then what we have to do, we have to replace it. Count plus plus equal to 0. Now this whole for loop, what it will do, it will keep track of all the non-zero elements, and it will place it at the beginning. Next, after that, while count is less than n, here what we have to do, once the elements are at the beginning, then at the end we have to put the 0 also. Array of count plus plus equal to 0. So that's it. This was your method 1. If you talk of the time complexity, then here it will move throughout the elements. It will move throughout the complete n loop. So this is taking big of n because it will start from 0 and it is going till n. Next, let's suppose you have x number of non-zero elements, then this one will take big O of n minus x. So if you talk of the time complexity, then this method is taking big O of n plus big O of n minus x, so a total of big O of 2n minus x. So this is your time complexity. At max, minimum time complexity will be that, let's imagine that there is no zeros element. That means this count will already become n, so this won't go into, so I can say at max it will be at minimum the time complexity will be big of n. If space complexity, it is not consuming any extra space, so I can say the space complexity will be big of 1. Let's go to the method 2. Method number 2, two-pointer approach. Like if your input array is 2, 0 1 0 0 4. Okay, let's your input array is this. We will take two pointer. One is I, which is single iteration, that is going from 0 to n, 0 to n, no problem. Then we will take a pointer j, which will point to 0. This one will point to 0. Okay, now why we are taking this? This is, we are taking j for swapping. Like, let's come here. If you see here, 2 is a non-zero element. Now since we have to put all the non-zero at the beginning only, so we don't need to touch this 2. 0, okay, 0, so this is j, this is your j. 1, so this is your I. Now it's a non-zero element, it's a non-zero element, so what we have to do, we have to swap this. So if you will swap this, then 1 will come here and 0 will become here, and j is pointing to 0, so we have to increase this to 0, and I will come here. Non-zero element, nothing we have to do, just we will increase the j. Again I will come here, 0, nothing we have to do, j will come here and I will come here. Okay, so again we have 4, again we have 4. So what we have to do, we have to, sorry, we don't need to increase j, we'll keep j over here only. Okay, again we have I over here, so we have to swap this with this, so this will make 4 over here and 0 will come here. Okay, and j will come to here and I plus plus, then loop ends over here. So what, quickly, I loop will goes from 0 to n and j is pointing to 0. Let's understand through this code. For let I is equal to 0, I less than n, and I plus plus. Now what we initially, we have to know the position of j, what is the first position of 0, then only from there we will start the swapping and all. So let's take j as equal to -1, because we don't know the position where the 0 is starting. So if array of I equal to 0, we got our position, j equal to I, then we have to break j equals to I. So we got the first position of what, 0. So if, let's suppose, if j is equal to -1 only, that means what, there is no 0, then we have to return what, whatever it is where the question says. Let's suppose return false, whatever the question is telling, or returns array. Okay, that means no 0 element over here, all are non-zero element, so nothing swapping and all we have to do. Now if there is a 0 element, then what we have to start the loop from, j plus 1. So for let I is equal to j plus 1, I will go from till n I plus plus. Okay, if array of I, is not 0, not equal to 0, then we have to swap, swap what, array of I with what, array of j. That's it. Okay, and then after swapping we have to increase j also. Now the loop ends. Every time, whenever the swap performs, we have to increase this j. So that's it. This was the coding part. If you talk of the time complexity, okay, so here it is going from 0 to n, so the time complexity for this loop will be big of n. Let's suppose there was no 0 element, that means at minimum it will take big of n. Now come to here, this part. Let's suppose let's suppose here we got x element. Okay, x element, so this will take big O of x. Okay. Let's get it properly. Okay, so let's suppose here x non-zero elements were big O of x. Now this loop is going from where? From x to n. This loop is going from x to n, so this one will be big O of n minus x, big O of n minus x. So the total time complexity will be big O of x plus big O of n minus x. X cancels, so I can say the total time complexity big O of n, and the space complexity, no extra space complexity, so big O of n. So the previous method was taking 2n minus x, and here the time complexity is big O of n, so this is the best method. So that's it for this question. I hope it is clear, and if you are still tuned, like to this channel, subscribe it. Thank you.